It was easy to show you the Pythagorean with a triangle this small, 3, 4, and 5. Let's see if we can do one with larger numbers. What if we had 5 and 12? What if those sides measured 5 and 12? What would the number of squares be in the hypotenuse of that triangle? Well, let's square these. 25 plus 12 times 12 is 144, and that would be equal to c squared. So 144 and 25 gives us 169 is equal to c squared. Now we've got to figure out what only c is. And this particular one isn't real easy to do in your head like this one was. But if we know our rules for how we work with square roots and the exponent squared, this becomes a fairly easy problem. In order to get rid of this square as an exponent, we would have to do the opposite of that and make it a square root. So we're going to do the square root of 169 and then the square root of c squared. Well, if you're doing c squared, we're making pairs, we would get 2 of these c's. So that means that one of the c's can come outside of this radical sign and just be a c. That's how they work. You know from this problem that 12 times itself is 144. Well, we're just a little bit bigger than that. So I'm going to think that it's probably 13. 13 times 13, we'll try that out. 3 times 3 is 9. 3 times 1 is 3. Here's our 3 and 1. 169. We're going to take one of the 13s outside the radical sign to match the pair, just like we did here. We took one of the c's, we call it c. We're going to take one of the 13s. So 13 is equal to c. Up here, this would have been 5 squared plus 12 squared is equal to 13 squared. So those would be pretty large squares that would come off of that triangle.